Okay, so let's look at the binomial distribution. So the binomial formula for AS statistics, and what this binomial formula says, the bi tells us that bi means 2. Okay, so there are only 2 options. So if you're only given 2 options, then you will look at binomial distribution. So what I want to do is take something that you're familiar with, which is football, and let's look at the Liverpool team, right? So what we have is, let's say we normally play a 4 at the back, and then we'll put Allison in goal. How many should we put in the midfield? What format are we going to play? 3-3-2.
Yes.
3 at the front.
4-3-3.
Okay, let's play 4-3-3. Right. So there's 3. Let's do this in. So what I'm going to do for this one, for the first one, is we're going to do 4-3-3, and let's say, because I've done Allison in green, so Allison would be my success of, like, let's say that we wanted to do the probability that one of the players that I choose is a goalkeeper. Okay, so this would be my sample size here, my 11 players. And we look at them, and then we want to work out, if I was to choose 4 players at random, what would the probability that one of those players that I picked was the goalkeeper, Allison? So when we look at it, we go, well, what is our P, your probability? So P, the green, so my success in this formula. So this formula means P is the chance of success. So P would be 1 out of 11, right? 1 out of my 11 players is a goalkeeper. Okay. Now, because it's binomial, I don't care whether the other players are midfielders or strikers or defenders. My Q is simply, let me just put that over just to, so, out of 11, and then our Q is equal to 10 out of those 11, right? Does that make sense? So success is 1 out of 11, and then the failure is 10 out of 11. So if I was to choose, if I was to look at now goalkeepers, midfielders, strikers, and all the different, or have all those probabilities, I wouldn't be looking at binomial distribution anymore. So in these questions that they ask in the exams, you have to look at, is it a success and a failure? So even if they ask you, like the question, say, with eyes, whether it's blue eyes or not blue eyes, because they don't specify the not blues into green, brown, and because they say blue or not blue, we're using binomial. Okay, so sometimes they'll disguise it. And so this, even though the Liverpool team is made up of a number of different positions, because you're only looking at, in our case, we wanted to know the chance of a goalkeeper versus not a goalkeeper, it's binomial. Okay, so that's the first bit, is the P is the success and the Q is the failure. And so if we wrote it in words, the success was a goalkeeper, 1 out of 11. Okay. And then the failure is basically not goalkeeper, because I'm not goalkeeper. And in stats, when you see this dash, it just means not goalkeeper, or you sometimes see a line on top as well. That means not goalkeeper. So that's the first part about this formula. Now the second part is this. This n means how many times. It doesn't mean n is not 11. N means, because the 11 is used in finding out the probabilities. the n is actually how many players am I choosing from these 11, or how many trials am I choosing? So if I was to pick it, say 5 times. So I pick one. Now what we need to take about this though is it's a large population. So when I pick a player and it's not Alison, I don't then keep that player and then choose another, because then my probabilities change. Because if I choose a player and he's gone and Alison is still there, and I choose from the rest of the team, I'm choosing just from 10. And that's a different type of probability. So what I'm doing here is I'm picking one, then I put him back, and then I pick one, and then I put him back. And so there's a chance that I may never pick Alison. And so that's a key point. So the n is basically the number of trials, or number of trials, or we could say number of when I say trials, I mean number of times I perform the experiment, right? And that's another way of saying it. So, the n could be 100, in which case, I could try this 100 times. N can be more than 11 because I'm trying it more than once. And so let's say that I do it 4 times. So we'll make n equals 4. So that means I am trying 4 times to see if I was to pick a player, what are my chances that I would pick Alison once? Well, then what I do is I try 4 times and I pick Alison once out of those 4. Well, then my probability of picking Alison is 1 out of 11, which I'm not going to put into you could put that often will just be a decimal. 1 out of 11, you put in your calculator, you get a decimal. And I choose him once. Now then, the other 3 must be the 10 out of 11, right? The chances that I don't pick Alison. And there would be 3 times where I would not, if I picked from 4 players, the other 3 times would be not Alison. Because this n minus k says 4, right, minus 1, which is 3. So that would be the probability that I picked Alison. And then, of course, this 4 combination 1 means that I could choose, there's a number of different ways I could pick Alison, right? So I could pick him on the first go, in which case the last 3 goes. So let's just do this. It's 1, 2, 3, 4, right? So we'll put Alison in green and the other players in red. So let's say I pick Alison on the first go. Well, that means that the next 3 would have to be not Alison. For me to just get 1 Alison, I want to pick Alison once out of the 4 times I do this experiment of just choosing a player. But of course, I could have also chosen a not Alison on the first go, in which case the second go could be an Alison, right? Or the third go could be an Alison, or the 4th go. So there's a number of ways I could pick Alison once. Does that make sense? Does that make sense? Okay, perfect.
Yes.
So this 4 combination 1, what it looks like in maths is 4 factorial over 1 factorial, because it's the 1, over 3 factorial. Now, if I was to write that out long ways, I can go 4 times 3 times 2 times 1 over 1 times 3 times 2 times 1. And what do I notice? The 3's all the 3, 2, 1 cancel. And I just get 4 over 1, which is 4. Right? And so this bit here is a 4. So this 4 combination just ends up being 4. Well, that's the 4 times, right? I could pick him first, second, third, or fourth. So that makes sense. And then let's look at the next bit. So this green bit here is the 1 Allison. So that could be over here. Right? So that would be the 1 out of 11. And then the 10 to the 3, well, that's 10 over 11. 10 over 11 and 10 over 11, which is, do we notice it's 10 to the 11 to the power of 3. So that's how we get the 1 over 11 and the 10 over 11 to the 3. And so my answer is just 4 times the probability of getting Allison times the probability of getting the other 3 players. So that would be a 3 there. Let's forget that 3. Okay, so now this binomial formula can work for anything, right? I could say, well, I pick 5 times. And what's the probability that I get Allison twice? Right, so if I can just change it to 5, then this would simply be 5 here. And this would be then twice that I choose Allison. And so my Allison's is 2. So I change this to a 2. But of course, because I've done 5, the 3 doesn't change. And because 2 and 3 adds up to 5, it always must do. And so that would be a 2 there. And of course, if I was to just add on, because I'm choosing now 5 different times, I'm performing an experiment. But of course, the 2 of those 3 have to be Allison, right? And so that's how I get 1, 2. So it's to the power of 2. Now the 4 would change because it was a 5 factorial. So let's look how the factorial changes. Well, it wouldn't be this anymore. Okay, it would be now. Let's see. So what the 4 would change to a 5, right? And the 1 and the 2 would both change. And so we would have a 5 factorial here, a 3 factorial, and a 2 factorial. And therefore, I would have a much more different answer. 5 times 4 times 3 times 2 times 1. Now, this is not as an intuitive as before, because we've got 3 times 2 times 1 times 2 times 1. Now look, we could have the first 2 being Allison. We could have the second and the third being Allison. We could have the fourth and the fifth being Allison. So there's so many different ways. So we really see how we need to know this binomial formula, because it gets so much more tricky. But if we just know how to plug things into the formula, it becomes easy. So we may not be able to, in our heads, figure out like before that there was 4 ways of choosing Allison, but we can actually just do the maths. We stick it in our calculator, the 3, 2, 1 cancel, and we get 5 times 4, which is 20, over 2 times 1, which is 2. So 5, so we get 10 different ways of choosing it. So this 4 would change to a 10. And so we see that as the problem gets more and more complicated, the probabilities become harder to calculate, although if we understand our binomial theorem, we're then able to work out these problems. Now, I'm not going to go into what the sum means yet. So we've only done this part. Okay. But just to say that this sum means this is like weird E, looks like a capital E combined with a Z thing. That means the sum of. And what that means is later on, we'll be able to see that we could add different probabilities together. So in other words, we could look at, say, what's the probability of choosing Alison less than 3 times? Well, that would be the probability of choosing Alison 0 times, because that would be less. But then there's also the probability of choosing Alison just once would also be less than 3, and choosing him twice would also be. So you'd have to sum all the different probabilities of the options of choosing Alison less than 3 times, because less than 3 means that there are even more different ways. And so you'd have to sum the different probabilities. So don't worry about the sum yet. We'll do that in the next lesson, but you could just put this in your calculator and you would find the probability fairly easily once we are familiar with the formula. Okay, so you can watch that video more than once if you need to digest it, and I will see you next time.